Everyone, welcome back to my YouTube channel. Again, this is Sir Robinson, your partner learning mathematics. In my previous video, we discussed the derivative of a function, and we use or define the derivative of a function using the slope of the tangent line. If you still remember, these are our objectives in our previous video. Let's continue achieving these objectives using some examples. Example number 1, we are going to find the equation of the tangent line to the curve f of x squared minus 9 at the point 4, 7. Before we solve this problem, let's try to understand what the problem really means. So, we believe that any function raised to the power of 2 that is a parabolic or quadratic function. So, meaning this one is, or x squared minus 9 is a parabolic function. Let's try to graph that one. We believe that is a leading coefficient positive, therefore that is a parabola opening upward. So the graph of x squared minus 9 is that one. What is the point 47? The point 47 in the graph that is located there. That is the point 47, right? So now, we are going to find the equation of the tangent line that touches at point 47. In short, what is the equation? Or what is the equation of the tangent line or that line B touches the point 47? In short, point 47 is the point of tangents where your tangent line touches. But the question here is, what is the equation of the tangent line? Again, we need to find the equation of the tangent line to the parabola. How are we going to solve that one? Since we are here dealing derivatives, we are going to use derivatives as a solution way in solving this one. So now, let's find the slope of the tangent line using the definition of the derivatives. What is again the definition of derivatives? MTL. What is MTL? That is the slope of the tangent line. Why do I have to get the slope of the tangent line? Again, your goal is to find the tangent line. Since tangent line is a line, we have to get the slope. Because the slope itself, as I told you, that is the behavior of a line. How your line works. So, in my previous video, this is the definition of the derivatives. The limit definition of the derivatives. At this case, I change of x to h to avoid confusion. Just to handle the equation smoothly. Look at, I change all my change of x to h. So, they are just the same. Just to make our equation kind of friendly. So, again, the given here is f of x, that is my function, x squared minus 9, and I have my point 47, or the ordered pair, or the point of tangency, where my line touches. Now, I have to solve the slope of the tangent line using this one. But how am I going to use that one? Or how am I going to solve this one? But before am I going to use this one, I have to find my f of x plus h, or this one, and also my f of x. The question is, do I have my f of x already? Yes. I already have my f of x. Where is my f of x? My original function, which is x squared minus 9. But I don't have my f of x plus h. So our goal here is to find my f of x plus h using this one. Of course, I will base that one to my original function. My original function is x squared minus 9. How are you going to use that one? Simply evaluating a function. Whatever inside here, or you are going to substitute x plus h in all the values of your x's in your function. So I have to put that one inside my variable x, and it will become like this. Again, x plus h put inside it in here or in the x, and it will become x plus h squared. Just copy squared, copy minus 9 here. Okay? After you evaluate that one, keep on simplifying. If you simplify this one, it will become like this. X squared plus 2xh plus h squared. How this one equivalent to this one? We believe that x plus h squared is equal to x plus, sorry for my handwriting, plus h multiplied to another x plus h squared. And if you're not fond of a mere simplification, you simply do the what do you call that one? FOIL method. If you do the FOIL method here, the result is x squared plus 2x plus h squared. Okay, so now I'll erase this one. Wait for a while. Very good. Okay, so now after you simplify, this one becomes x squared plus 2xh plus h squared minus 9. Keep on simplifying. The result is x squared plus 2xh plus h squared minus 9. Therefore, we already have x plus h in this form. So after you solve your f of x plus h, you go back to your original formula. Let me erase all this. There you go. So you substitute in your original formula. That is my original formula. Question is, do I have my f of x plus h? Do I have this one already? Yes. I have that one, which is this one that I simplified or solved earlier. Do I have my f of x already? Yes. I have that one as the original function. Just substitute. As you substitute that one, that is, or it becomes like this. This one is all here. You put it inside here. Copy minus sign. And f of x is x squared minus 9 all over h. Then after that one, keep on simplifying. What happens here is we distribute the negative sign to x squared and negative 9. And it becomes negative x squared plus 9. Okay. Again, this is the limit definition of derivatives. Once you substitute 0 directly to your denominator, your function becomes undefined. And that's a big no-no. We have to find this. Now, let's look at this one. We already simplify and it becomes like this. Take a look at this one. We have x squared here and we have negative x squared over here. If we're going to simplify that one, x squared minus x squared, it becomes 0. So meaning x squared is cancelled. Observe other things that can be cancelled out in this form. Do we have something to cancel to 2xh? No, we don't have similar that has x and h. Do we have h squared over here? We don't have as well. Observe that we have negative 9 and positive 9. Negative 9 plus 9, that is also 0. So we can able to cancel that one out. So what is the remaining now is the 2xh plus h squared because everything is already cancelled. Now, can we now substitute 0 directly? Still no, because your denominator still becomes 0. So continue. So as you can observe, my numerator has both h and h. In short, you can able to factor that one. H is factored out because both terms has h and all over h. Can we now cancel h both numerator and denominator? Yes, we can able to cancel h and another h here. Cancel that one out. What is the remaining now is 2x plus h. Another question. Can we now substitute 0 to our h now? Yes. We can now substitute here or we can now use the limit simply because our function is no longer undefined. If we're going to simplify that one, it will become 2x plus 0. Take note that you are not here to substitute 0 to x because your variable here is h. Therefore, you are only to substitute 0 to all h, and I have only h here. That is why it becomes 2x plus 0. And continue simplifying, that is now 2x. I'll erase all the... There you go. Meaning, the limit or the slope of the tangent line here is 2x. Are we done? No, we are not done yet because 2x is not the equation of the line. So let me erase some of the solutions in my PowerPoint. There you go. Thank you so much. Okay. What is 2x here? From your solution, you get your answer from using that one, you get your answer. Take note that beside your 2 here, we have variable x. And going back, we have this point, 4, 7. We believe that 4 here is our x, ordered pair x, and y, which is equal to 7. What are you going to do? You get the 4, or the value of x in the point of tangent C, and substitute it here to become 2 times 4. And that is equal to 8. Therefore, the slope now is 8. Question is 8 our answer? No, we are not done yet because 8 is not yet the equation. That is still the slope of a line. So you already have the slope using the formula. Let's try to clean my PowerPoint. Okay, there you go. Thank you for that one. Thank you so much. Thank you. And some arrangement. Very good. You already solved your slope of a tangent line. You have this point and you have the function. After now, let's find the equation of the tangent line. In short, the goal earlier is to only find the slope. And that's how you find the slope. So, to find the equation of a tangent line, you have to use the point-slope form. Why the point-slope form? Because we have a point of tangency here, and we already solved the slope over here. So you have, that is the point-slope form, is the point-slope form, y minus y sub 1, m for the slope multiplied with x and x sub 1. What is y sub 1 and x sub 1 here? My x sub 1 and y sub 1 is the point of tangent C, which is this is my x sub 1 and this is my y sub 1, or the point of tangency. You are going to substitute that one here and over there. And your slope which is equal to e. There you go. In substituting, it becomes y minus 7 is equal to 8 times x minus 4. By simplifying, 8x minus 32 and using the general form, it becomes y is equal to 8x minus 25. There you go. That is now the equation of the tangent line. Y is equal to 8x minus 25. The equation of tangent line now is y is equal to 8x minus 25. Finally, we are done. That's how you solve the equation of the tangent line. First, kinda long, right? So, what we did is a brain, they call that one brain drain. But just follow the concept. That's how everything works in solving the equation of a tangent line. So meaning, in this example number 1, the equation of the tangent line of the curve x squared minus 9 at the point 47 is y is equal to 8x minus 25. That is example number 1. Let's proceed to example number 2. Of course, for you to practice how it works, it's your time to solve example number 2. I will not solve it for you. You follow example number 1, but I'll give you the answer. The answer for example number 2 is y is equal to negative 6x plus 13. You find it in yourself. Let's see if you understand this video.